Hi everyone, welcome to Challenge Galaxy again. And today I would like to share with you it's an interesting algebra challenge, and it's rather quite simple. But I would like to explore the approach that we can take here, as well as the strategy and some interesting ideas in between regarding long division and factorization, and the power that it provides us. So to begin with, I've written the problem down here. As you can see, solve x is equal to x minus 1 over x in brackets to power half plus 1 minus 1 over x in brackets to power half for x belonging to real. Okay, so what can we see here? We start off with the problem. I will just write it again here so that we can begin. We have x is equal to x minus 1 over x to power half, so it's going to be the square root, plus 1 minus 1 over x to power half. Just to make sure I've written that correctly. Okay, so what can we see initially? So first of all, this power, the rational powers, and so there are roots involved, and I don't really like that. I believe that if we work with simple polynomials, so the power of x would have integer powers, that would be much easier, and we are much more equipped to deal with that, as we have long division techniques, factorization techniques for polynomials. So let's start off. So the goal we can have in mind initially is to make sure we remove all the surds and simply begin dealing with integer powers. And we should also keep in consideration that we can make sure to factorize this as much as possible throughout, because at the end we're going to solve a polynomial by factorization, as this is a non-calculator challenge. So to start with, what can I do? Well, I can see that this is a fraction inside, so let's already write this in a different form. So all we can do is we can say x squared minus 1 over x to the power 1 half plus the x comes here, x minus 1 over x to the power 1 half. And I did this because now we see x squared minus 1 is just the difference of two squares, and hence we can just write this as x minus 1, x plus 1. So therefore x is equal to x minus 1, x plus 1 whole to power 1 over 2. And I'll also just bring this, let's just make this x to the power 1 over 2, already multiply the power out here, exponent out here. And then on this side we just have x minus 1 to the power of 1 over 2 over x to the power 1 over 2. And already we can see that this x minus 1 to the power 1 over 2 is a factor that will come out, and x to the power 1 over 2 is also common, is a common denominator, so we can just bring these two fractions together. Or we can already multiply throughout by x to the power 1 over 2, which is just root of x. So I'll do that already here, and then we can do x to the power 1 over 2 is equal to x minus 1 to the power 1 over 2 times x plus 1 to the power 1 over 2 plus, we also have here x minus 1, so x minus 1 to the power 1 over 2. And we know that this on this left hand side it's just x times x just to the power 1, so we have x to the power 1 plus 1 over 2, so x to the power 3 over 2, that is our power on this side, is equal to, I'm also going to factor out x to the power x minus 1 to the power 1 over 2 over here, and I can take that out here, so I get x plus 1 to the power 1 over 2 plus 1. And so let's see, we still have surds, we still have rational coefficient powers. So what we can do is I'm going to square both sides now. And the reason for factorizing this still here is now when we square, we just have to square each binomial here, or each part, instead of dealing with expanding out both in the brackets. So if we just square this, we get x to the power 3 is equal to x minus 1. 1/2 times 2 is 1. And then here we get, inside this, I'm going to need to expand this, and we get, so I'll write it down first, and then we can expand it. X plus 1 to the power 1 over 2 plus 1 to the power 2. So already on the left-hand side, we have removed our rational coefficient, sorry, power, coefficient. And we have also removed that to this x minus 1 term here. And we can already divide that on the other side. So I bring the x minus 1, divide on the other side. And here, we can just expand this out. So we get x plus 1 as x plus 1 to the power half squared. This is x plus 1, and then plus 2 times x plus 1 to the power 1 over 2 plus 1. And already we can see there's only one rational exponent left here, which is the x plus 1 term. And so what we can do is if we take it to one side, and if we square both sides again, that would be removed. So what I'm going to try doing is I'm going to take this on this side. So I'm going to move everything else on the other side. So all I can do is I'll just leave this here, x plus 1 to the power 1 over 2 is equal to x cubed over x minus 1. And we can already see here this was x minus plus 1 and 1 here, this one here. So we can just add that to make x plus 2. So I'm going to take the, on the other side, I get minus x plus 2 there. So before I square this, I don't want to be dealing with an expansion again. If I working with factors, it's much easier because I just, again, raise each term, not term, but each binomial or each everything in the bracket to the power. So I am going to use the common denominator on the other side. So let's do this. So we get x cubed minus x plus 2 times x minus 1 over x minus 1. And so let's expand that. On the other side we get 2 times x plus 1. 2 is equal to x cubed minus x squared minus x plus 2x. So I'm put it back here. X squared minus x plus 2x. So that will give me plus x. And then on the other side I have just minus 2. All over x minus 1, of course. And now we can just multiply out the minus sign here. So we're already close. So x cubed minus x squared minus x plus 2 over x minus 1. And you may be thinking, why did I just expand it out again? I was just talking about factors. But the goal here is to achieve this polynomial in the numerator, because I mean, with a polynomial, we can try factorizing it. So if I think about this, this polynomial here, this is very important. Why? That's the deal. So if I write this here, this polynomial, if I can express x cubed minus x squared minus x plus 2 as some multiple of this x minus 1 term plus some constant remainder, then I would be in a better position to square this out quickly. And I believe that would be a better factorized state as well, because of course they can have different factors. So what I'm going to do here is let's do a long division. So I'm going to do this in red. Let's go here. X cubed minus x squared plus 2, and we're dividing it by x minus 1. So let's see what we get. We can do x squared here. You get minus x cubed minus x squared. So both of these terms are gone. And then we're left with minus x plus 2. And here's the trick. The remainder that we're going to find actually is 1, because if we go down, we can multiply this out by minus 1 now. And what do we get? We get minus x plus 1. And if I subtract this, minus x minus minus x is minus x plus x, so that's 0. And then 2 minus 1 is just 1. So we can see that this is a remainder, and that implies basically that our initial polynomial, x cubed minus x squared minus x plus 2, is just equal to x minus 1 times x squared minus 1 plus 1. And why is this so much better? Well, we can already see we just have a difference of 2 squares here, x squared minus 1, and x minus 1 is also one of those factors there, so we know that'll be x minus 1 whole squared, and we just have a simple 1 to worry about when squaring that. We have no problems there. So I think this is much more easier, and you'll see what I mean as we following the problem. So if we just replace that here with what we got right now, let's make this a bit bigger. So we got this, we get 2 times x plus 1 to the power 1 over 2 is equal to x minus 1 square. I'll already just express the difference of 2 squares, that it was a difference of 2 squares, which we discussed, plus 1 over x minus 1. And this will now we're ready to square it. So what we can do is we just go here. Let's square both sides. And this is much easier because we just have the 1 to deal with when we are expanding. So we get x plus 1, 2 squared. So 4 is equal to x minus 1 square plus times x plus 1 plus 1 square over x minus 1 square. And I'm going to just multiply this out already. So 4 times x plus 1 here, and is equal to, if we expand this, we get x minus 1 square times 2. So that will be 4. 4 x plus 1 square. So we square the first term. Then we can do plus 2, because that's just a 1, times x minus 1 square, x plus 1, and then we just get plus the 1 at the end. And of course, at the bottom, we just have x minus 1 square. I will leave that as that is, because that's already in factorized format. So x minus 1 square. We're really close. So all we need to do is we just take the x minus 1 on the other side, and we just get 4 x plus 1 brackets times x minus 1 square is equal to x minus 1 4 to the power 4 x plus 1 plus 2 times x minus 1 square x plus 1. And I already see something interesting here with the x minus 1 square times x plus 1, which we can see here that this is actually a quadratic in x minus 1 square times x plus 1. And I will bring this on the other side to show it to you. So if we take this on the other side, do this in red. So we have, if I bring the 4, the term with the 4 as coefficient on the other side, we get x minus 1. Here, this will remain 4 x plus 1 square minus 2 times the x minus 1 square here, x plus 1 plus 1 is equal to 0. And if we look at this here, this is just x minus 1 square x plus 1 whole square minus 2 times this x minus 1 square x plus 1 plus a 1 at the end, and this is a quadratic in x minus 1 square times x plus 1. And not just any quadratic, this is a square of a minus b. If we think about it like this, it's just the square of a minus b as, the coefficients are 1, minus 1, minus 2, and 1. So 1, minus 2, and 1. So if I let some u, just to make this easier, let it be x minus 1 square x plus 1, then this expression simply transforms into u square minus 2u plus 1 is equal to 0. And this, as we know, is just u minus 1 whole square is equal to 0 in this case. And this is what I was talking about, the factorization. This is why it's so powerful here. And now this is we're already practically solved, as we just need to now solve this for the values it is asking. Let's zoom in. So we can just go here and we can go into black again. So we have, this is just u minus 1 is equal to 0. That's the square root of 0 plus or minus 0 is just 0. And now we can replace it again. So I write here as u is equal to x minus 1 square times x plus 1. This implies that x minus 1 square times x plus 1 plus minus 1, sorry, that's 1 is equal to 0. And now I think it's better to expand it, as we only have 2 terms. So we can expand this now. And if we do this, instead of expanding fully, I can already see that it's x minus 1 times an x plus 1. So I can already make this a difference of 2 squares, which is just this, times the other x minus 1. Minus 1 equal to 0. And if I expand this out, I get x cubed minus x squared minus x plus 1 minus 1 is equal to 0. And we're not really dealing with we are dealing with the cubic, but this is very easy to solve because we just have x cubed. If minus 1 plus 1 goes away, and we just, as you can see, if we take the x out, it's again a quadratic, which you can quickly solve. So we just take the x out, we get x squared minus x minus 1 is equal to 0. Implies that x equal to 0, or that's one solution already, or x squared minus x minus 1 equal to 0. And if we look at the discriminant here, b squared minus 4ac, so that will be 1 squared minus 1 squared, which is 1, minus 4ac, so minus 4 times minus 1, 1 plus 4 is 5. So root of 5, 5 is already positive, so we know it's a real solution. And by quadratic formula, I would just write that here, just to remind our memory again. By quadratic formula, which of course is x is equal to minus b plus or minus root of b squared minus 4ac over 2a. So let's just go back to our solution here. And that is, therefore, x is equal to minus times minus 1 plus or minus root of, as we already saw, it was root 1 plus 4 as b squared, which was minus 1 squared, plus minus 4 times minus 1 times 1, of course, the first coefficient was 1, over 2 times 1. Applies x is equal to 1 plus or minus root 5 over 2. And just to check, what was the domain they initially gave? X belonged to real. And all 3 of these solutions are real. So applies x equal to 0 or 1 plus or minus root 5 over 2. Those are our 3 solutions to this problem. So thank you for watching. I hope you enjoyed. I really I enjoy this problem because it again displays the power of factorization and how it can make seemingly difficult problems with surds be very simple. And please don't forget to like, share, and subscribe. And I hope to see you next time.